All right, let's dive into a really cool scientific puzzle. Seriously, it's one of those things that seems impossible at first, but once you get it, it changes how you see the world. And we're going to solve it together. So here's our mystery. You've got diamonds, right? They're the hardest natural thing we know of, super beautiful, and they can literally cut through steel. Then you've got graphite. That's the stuff in your pencil. It's so soft it just flakes right off onto the paper. Now get this. They are both made of the exact same thing, 100% pure carbon atoms. So, how is that even possible? To crack this case, we need to think like detectives. We've got to gather some clues, and our investigation is going to start at a scale so small you can't even imagine it, with the basic building blocks of, well, everything. Our first stop is the world of atoms. These particles are unbelievably tiny, but believe it or not, the secret to our whole carbon mystery is hiding right there. So what is an atom? Basically, everything around you, the air you're breathing, the chair you're sitting on, it's all made of atoms. The easiest way to think about them is like they're the universe's own Lego bricks. Different atoms are like different colored bricks, and they snap together to build everything. Now here's where it gets really interesting. Those little Lego bricks, they don't usually just float around by themselves. Nope, they love to connect. And when two or more atoms get stuck together, scientists call that a molecule. The glue that holds these atoms together is a force called a chemical bond. And atoms are not picky. They can bond with other atoms of the same kind, like two oxygen atoms joining forces to make the O2 gas we need to breathe. Or they can link up with different kinds of atoms, like when two hydrogen atoms and one oxygen atom make a molecule of H2O, water. Okay, so atoms can form these small groups, but they can also go way, way bigger. They don't just stop at simple little molecules. Sometimes you get bazillions of atoms all linking up in these huge, organized, repeating patterns. This isn't just a small group anymore, it's a giant network that we call an extended structure. And I promise you've seen these before. Next time you're about to sprinkle salt on your food, take a really close look. You might see that the grains are perfect little cubes. That shape is no accident. It comes from its atoms being locked into a perfect repeating pattern. That's what makes salt a crystal. Okay, so this is it. This is our big clue. The incredible variety of stuff we see in the world isn't just about which atoms you use. It's all about how you put those atoms together. The arrangement is everything. All right, we've got our clues. We know about atoms, we know about bonds, and we know about structures. Let's head back to our diamond and graphite problem and solve this thing. So, the huge secret behind why one form of carbon is super hard and the other is super soft, it has absolutely nothing to do with the carbon atoms themselves. It is 100% about how those atoms are arranged. It's all about the structure. Check this out. In a diamond, every single carbon atom is locked tightly to 4 of its neighbors, creating this incredibly strong 3D web. It's all interconnected. But in graphite, it's a totally different story. The carbon atoms connect to form flat sheets. Now, the sheets themselves are strong, but the connections between the sheets are super, super weak. It's like a deck of cards, right? Each card is pretty tough, but they slide past each other with no problem. So let's zoom in on the diamond again. You've got these crazy strong bonds pulling in every single direction. This creates a solid, rigid structure that's almost impossible to break apart, and that's exactly why it's the hardest natural material on the planet. Now, let's look at graphite. Those strong bonds only exist on the flat plane, creating those neat little sheets. But between the sheets, the forces are so weak, they're barely there. So when you write with a pencil, you are literally sliding off layers of carbon atoms from the tip onto your paper. And just like that, mystery solved. This whole idea that the structure of atoms determines what a material is like, that's not just a fun fact. It is a massive rule in science and engineering that people use every single day to build the world around us. Let's look at this idea in action with a different element, silicon. Silicon is the key ingredient inside most solar panels, the part that actually turns sunlight into electricity. And guess what? Just like with carbon, how you arrange the silicon atoms changes everything. If you arrange them in a perfect, orderly, repeating pattern, that's called crystalline silicon. You get a super efficient solar panel. But if the atoms are all jumbled up in a random arrangement, that's called amorphous silicon. It's less efficient, but it's also cheaper to make, and it's flexible. You might see it on a solar-powered backpack or a calculator. It's the same atoms, just a different structure for a different purpose. So,
The big takeaway here is that the recipe for making any material has two crucial parts. You've got your ingredients, that's the atoms, and you have your instructions, that's the structure. If you change the instructions, even with the exact same ingredients, you get something totally new.
And that leaves us with a final, really exciting thought. If we know that arrangement is the key, what incredible new materials are we on the verge of creating? What kind of problems could we solve just by rearranging the universe's Legos in a new way? Pretty amazing to think about. Thanks for exploring with me today.